So hello students, welcome back to our video classes, and today we are going to go through the last chapter of metals and non-metals. So I think uh, you have gone through the other videos before coming to the last chapter, because in this video is not going to be that much long. The length of this video is going to be very like near about half an hour or 45 minutes. Okay, and I think you have gone through the other videos. So this video, if you have gone through them, then only this video is going to be 45 minutes for you. Otherwise this video is going to take a little bit longer than that. So I think in the last video you have seen that we were dealing with some extraction processes. So in the last video we were dealing with like how to extract the metals, right? And there were three types of extraction processes, and I think I've gone through all of them. And the most important thing is for the extraction process for aluminium. If you haven't gone through the last video, then please go through it, because extraction of aluminium is really very important. Okay, and like how we are mixing cryolite and fluorspar with it, and why were we mixing it. These ideas are needed. Apart from that, we have discussed about how to separate out the very like reactive metals, the moderately reactive metals, and as well as the weakly reactive metal. Like those are not reactive that much, right? We have discussed about them as well. Now, for the reactive, I think you remember we were saying that this is for electrolytic refining, electrolytic reduction. For moderate reactive and for less reactive, we use a reduction process, which is for less reactive. That is generally, for the less reactive, like copper. If I take copper, so copper oxide, if you just copper sulfide, okay. So if you just give it for roasting, okay, when you roast this copper sulfide, you get copper. Okay, you don't have to work a lot for that. So you just roast copper, you'd get some copper oxide, right? And the speciality about it, this copper is, this copper oxide reacts with this copper sulfide. Okay, and copper sulfide and copper oxide, they react together with each other to give you copper and sulfur dioxide. This reaction is called self-reduction, and the copper we get from here is called the blister copper. So these were the things, okay, are called the blister copper. So that is how you can take out this copper oxide. So via roasting only, you can take out the less reactive elements. And for the moderate reactive, first you have to do roasting, followed by a carbon reduction, right? Coke with. Now, after, as I told you, if you remember in the last video, I told you like this electrolysis method, the thing that we use to separate out the reactive elements, that I told you when I taught you this part, I told you that this is going to be used for refining of metals as well. As I told you, today we are going to read how we can refine metals via this electrolytic method. Apart from that, we are going to read about corrosion and how to prevent the metals from corrosions. Okay. So the first thing is refining of metal. The process of purifying impure metals is called the refining of metals. This is the most common and widely used method for refining impure metals, is called electrolytic refining. So the thing is, via the processes like calcinations, or calcination or roasting, and if needed, followed by carbon reduction. So the metals we get from here, the metals, they are, as I told you in the last class, they are near about 70 to 80% pure. But you know what? If I just take a metal which is this much pure, then this is not going to work, right? This is not going to work. So we need a very pure metal, like more than 95%, to work with it. Okay. Now how to do that? So in the last process, we need to take out the impurities out of it, right? Now to take out the impurities, the thing we do is we do electrolytic refining, as you can see. So we do electrolysis only, but the process is going to be very simple for you. If you just Yeah, look into this picture over here. So this is just thing but a voltmeter. This is a voltmeter. Okay, now look at this voltmeter. Here you can see the cathode, and cathode is negatively charged, as you know, and anode is positively charged, as you can see over here. Okay, now what happens is when you give it some copper. Okay, when both of the cathode and the anode, both the electrodes are made up of copper. So both the cathode and the anode, this is the cathode, this is the anode. Okay, this is the battery. Okay, both of them are made up of copper now, cathode and anode, both of them. So this is going to be negative charge, this is going to be positive charge. Now if in the beaker, if I put some copper sulfate solution, a blue copper sulfate solution, then what would happen? Then definitely, you know, in the first place, on the first step, copper sulfate is going to get broken into Cu2 plus and SO4 2 minus. Cu2 plus and SO4 2 minus. And now this Cu2 plus, this Cu2 plus is going to go towards the electron. Okay, towards the cathode. Because cathode is negatively charged, for that reason, what would happen is this Cu2 plus would go towards this cathode. Now, what would happen in the cathode? Okay. In the cathode, what would happen? And in the anode, what would happen? Let's see. Now, so in the cathode, copper 2 plus goes to the cathode. So cathode has so much amount of electrons. So it just takes out the electrons from the cathode to give you a pure copper. So Cu2 plus takes out 2 electrons from the cathode to give you copper. So what would happen is the cathode, okay, the cathode, it would take out the copper. Okay. Now, the anode is also made up of copper, but there is a difference in between the cathode and the anode. Okay. This copper is the impure one. This copper over here, which is the anode made up of, this copper is the impure one. Impure one means the copper you got from the several processes. But the copper which is in the cathode, this is going to be the pure copper, only the purified copper. So this is pure, and this one over here, this is impure. Okay, and this was what it is going to happen in cathode. So in cathode, you would be able to see that the copper would get deposited from the copper sulfate solution. So this is the copper sulfate solution that breaks down in copper 2 plus and SO4 2 minus, and this copper goes and gets deposited over here. Okay, so this is the reaction that happens. Now I need some more spaces. Just give me a moment. Just give me a moment. Yeah. So I fixed it. So yeah. So what happened is in the cathode, what happens is the copper 2 plus came and takes up 2 electrons from the cathode to give you copper, which is deposited on the electron. So if this is the cathode, so what would happen is the copper from the solution. Just give me a moment. I'm just trying to draw the entire voltmeter again. Okay, so this is made up of copper, the cathode, which is completely pure, and this is made up of also made up of copper but impure, that you want to purify, right? This copper is the one that you want to purify. Now what would happen is, if you just use the copper sulfate solution, the thing that would happen is it would first break down in Cu2 plus and SO4 2 minus. Now this Cu2 plus would go towards the cathode, right? It would go towards the cathode. Okay, now after that, what would happen? Now in the anode, what would happen? Let's see. Let's see the anodic reaction. Now just remember this. There are so many reasons behind it, but for now just remember it. Okay, when the cathode anode, cathode and anode both are made up by a particular metal, and the electrolyte taken, and the electrolyte is a salt of the same metal, then what would happen? Then this thing happens that right now we are going to do. So let's see what would happen. Just remember this, okay? So you can see the cathode and the anode are both made up of same thing, and the solution is also of copper, right? So in this situation, what happens is, in the anode, this part is the most important. You might be thinking that in the anode SO4 would be going there, right? But instead of SO4 going there and getting oxidized, here the reduction occurs. Instead of SO4 going to the anode and getting oxidized, what happens is Cu, copper over here, the copper which is there in the electrode, that copper gives up 2 electrons to the electrode, which is positive over here. This copper gives up his two electrons, okay, to that electrode, and itself becomes Cu2 plus, and it falls into the solution as Cu2 plus. So what happened just now? Cu2 plus from the solution went to the cathode, and Cu2 plus from this electrode went to the solution. So in the solution, Cu2 plus concentration remains the same, isn't it? So in the solution, the Cu2 plus concentration remains the same. But what would happen? But what would happen to the other things? So if this is the cathode and this is the anode, this would get corroded, and it would all the copper from this anode would get deposited in the cathode, all the copper. Now think about it. If this electrode is made up of impure copper, then all the impurities inside that electrode, all the impurities in that electrode would get sedimented in the solution here. It would get sedimented down in the solution, and only the pure copper from the electrode would go and would get deposited, get deposited in the pure copper electrode. Did you got the point? You might be thinking why this is happening, right? So, when you would get into class 11 or 12, you'd be reading the potential values. The potential values. You can also search it in the internet as well. So the thing is, the potential of SO4 2 minus to get oxidized is lesser than the potential of Cu getting oxidized to Cu2 plus. So for that reason, it happened. For that reason, this thing happened. So this anode would get corroded with time, and this cathode would get thicker and thicker with the pure copper only. All the impurities would get deposited over here, and that impurities over there which is deposited are called, these impurities are called anode mud. Anode mud. Okay, so this is the entire process. Okay, I think you got it. Now we will move on to the next part, which is the corrosion. Now, what do you understand by the word corrosion? The eating up of the metals by action of air, moisture, or a chemical on the surface is called corrosion. So far, you have heard about iron getting corroded, isn't it? When iron gets corroded, it gives you rust, right? Fe2O3.XH2. We don't know how many amount of water would be there attached there. So for that reason only we write it XH2, and we call it rusting. You can see it over there. Here, this is a picture of rusting. This is a brown precipitate over the brown layer of formation over the iron surface. That is called rusting. Now, what is the formula of rust? How this rusting is formed? When this iron is exposed in the atmosphere. So the oxygen of the atmosphere and the water vapors together, they just react with the iron to give us Fe2O3.XH2, which is known as rust. Okay. Also, it is also known as ferric oxide. Now, this is about rusting, and rusting is a type of corrosion. Same thing happens for silver as well. Same thing happens for copper as well. Like all the metals gets corroded. Okay. Now, so I think you can understand, if the metal gets corroded, what happens is its reactivity decreases. Its reactivity or usefulness, whatever you say, would get decreased. For that, what we do. So conditions necessary for rusting. Okay, the conditions, which is the presence of air and the presence of water or moisture. That is why when I wrote the formula, I wrote like O2 and H2O. Okay, so without the presence of this air and moisture, you would not be able to form Fe2O3.XH2. So you need both of them. You need both of them. So this is a pure oxidation reaction. This is a pure oxidation reaction. Fine, we got it. So this is oxygen and iron. So what happens is, if this is our iron object, you'd be able to see that there would be a formation of a little bit brownish sedimentation over the surface of the iron. If this is iron, there would be a brownish sedimentation over the surface of iron, which we call rust. So what it does, it decreases the chemical reactivity. It decreases the chemical reactivity. Okay, for that reason, we need to take measures so that we can prevent rusting. Now, prevention of rusting can be done. This prevention can be done via two methods. Okay, one is metallic coating, another one is non-metallic coating. Okay, now understand about them. This metallic coating can be done in so many ways, like tinning, like giving a tin layer over it, or via galvanization. Okay, giving it a pure zinc coating, or you can also do nickel or chromium, this coating. Okay, you can also make some alloys with it. I think metal mixtures are called alloys. So sometimes they make stainless steel, right? Instead of steel giving steel, they did make stainless steel. And this stainless steel over here, they are going to be very much useful because they don't corrode, right? They don't get rusted. Now the other one is the non-metallic coating. Now non-metallic, what are the processes through which you can do? You can do enameling. Apart from that, you can also take care of this by via enameling. Enameling is one. Another one is lead paint. Lead, not lead paint, it should be lead oxide paint. Okay, so the red colored painting, a red color. Okay, and so these are the processes, so non-metallic processes through which you can do that. Okay, now this lead paint, this enameling, and the other types of you can do other things as well. So like you can also use oils. Okay, you can also use oils. So there are so much mosquitoes over here, that's why I'm getting distracted over and over again. Okay, now the thing is, there are oil and enamels. Like you can just put some rub some oil, isn't it? I think you have seen, like sometimes we just in our cycles we just use some oils or some grease, right? That is the thing I'm talking about. Apart from that, you can do enameling. Apart from that, you can use lead paint to stop this thing. So we are going to going to deal with them one by one. The first one is the lead painting, non-metallic process. So you can do via painting. So I think you have seen, like there are so many bridges, in cars. So if you have ever ever like ever given someone like what I mean to say is, like take some metal objects, okay, and give them to the blacksmith. Okay, give that thing to the blacksmith to make some repairings or something like that. Okay, when they would give it back to you, they would just paint something red over it. Okay. And you have also seen that most of the time the water pipelines, they just paint that thing with red. So that is normal, not a normal red color. So that is red lead. That is normal. That is not normal red color. That is red lead. Basically, red lead oxide paint. And you know that lead is not a very good reactive element, right? Right. This is a very bad in reactivity. Okay, for the metals. For that reason, if you just give it a coating of lead, then definitely the iron behind it, the iron inside it, would not react, right? So that is how we can do it via prevent it via painting. Another one is grease oil. As I was saying, this thing you can do, right? So applying grease oil on the metal surfaces, what happens is this just gives it a coating, gives it an extra coating, so that the outside oxygen and water, they don't get in contact of the iron. There is a theory in class 11th, in class 12th you would learn. Okay, the theory is called a collision theory. So collision theory, according to this theory, if two particles do not collide with each other, if they do not collide with each other, there is no reaction. There is no reaction. So to react two elements together, you need to keep them in contact to each other. Okay, so if there is a layer of iron over the surface of the iron block, if there is a coating of something else, any lead oxide or something like that, what would happen is these two things would not be able to get in touch with that, and the rusting would not be there, right? Another process is galvanization. So what is galvanization? Let's see. Like if you take an iron object, again, if you just give it a coating of zinc, if the metal with which you are coating it, if that is zinc, then this metallic coating, is known as galvanization. This metallic coating is known as galvanization. As you can see in most of the iron objects, we just give it a coating of metals, different types of metals. You can use tin plating as well, or tinning, chromium plating. You can use nickel. You can use nickel plating as well. So all the same, right? The main idea is to give it a coating so that the iron would not get connected to the oxygen or and water. Without that, no rusting would be there. Fe2O3 formation is impossible without that. So we can do these type of platings, electroplatings. Okay. So that was all about the prevention of corrosion via the metallic processes. And now the thing is, this is how we can do it via making some alloys. Okay. We have seen like there are so many alloys like bronze, like stainless steel. Yes, you have heard about that. Stainless steel. Now this stainless steel, all these things are just the alloys of iron, right? Iron with chromium and different types of objects, right? Nickel, chromium, those type of things only. When they mix with them, what happens is that is not a pure iron anymore. So there would be no rusting. There would be no rusting. Okay, so that was all about the formation of alloys and how to prevent that via making the alloys. Now in this part, like we have come to the verge of ending this video as well and ending this entire chapter as well. So what are the three types of corrosions? Okay, you can see there are 5 general types of corrosion. Okay, galvanic corrosion, stress cracking, general, localized, and caustic agent corrosion. So most of them, like caustic agent corrosion and like this thing, is you can see like via the corrosion which is forming via the presence of the alkalis. Okay, and the other corrosions, there are different types of corrosion. You don't need to learn about them in detail. So okay, this is something which is frequently asked. Okay, for that reason we are just teaching this thing to you. Okay, so I think that was the first question for FAQ. Then the next question comes like this: what is the chemical formula of rusting? So I have told you a number of times, when iron gets reacted with iron, oxygen, and water, these two things comes from air, right? So the thing we get is Fe2O3.xH2O. So this is rust, right? This is called rust. You can see over here, providing the electrons above the reaction. So they are just giving you all the things in the electronic manner. Okay, just go through it. There is nothing important written over here. The thing that you have to do is, this is the formation of Fe2O3 only. Okay, you don't have to go through them in details right there. So that's all about it. And if you have any doubt, you're just going to write it on the forum. And I think you enjoyed the entire session with the entire chapter with me. You have got it, right? And if you have any doubt, you just write it on the forum and definitely one of us will reach you. And that's it, I guess. That's it for today. And that's it for this video as well. And just keep learning from Ask IITians and see you soon. Bye, everyone.